What I'd like to talk about is yes, it's about technology with Microsoft Fabric, but it's really the step before that. This proof of concept, this something that you want to do to see if this is something that's actually going to be useful and a success within your organization. So this is up and running. How to make your Microsoft Fabric proof of concept a success, or as much as possible. We'll kind of define what success means for a proof of concept. So, well, firstly, thank you for joining. I appreciate your time. I hope it's going to be useful over the next 45, 50 minutes. I'll make the slides available. I think David might put them on the website. I'm on Blue Sky rather than Twitter now. I'll be on LinkedIn, so you can just find me on LinkedIn, Andy Cutler. And one of the things that I also do is I co-organize with a couple of other people, and we do Data Toboggan, which is, again, it's an online hosted conference where we talk about Fabric, we talk about Synapse. It's more data engineering, data warehousing. It's less on the, let's say, the Power BI, the modeling, the visualizations, and AI side of things. We kind of concentrate on the data engineering and warehousing. Well, firstly, thank you to David for putting this together, the Global Fabric Conference. So, hats off for putting it together. And of course, the experts and the volunteers, so Kay, Gilbert, Martin, Mehrdad and Rajendra. Thank you very much for, stepping into the conference and helping out as well. It is always much appreciated. Otherwise, conferences don't really happen. It's very simple. We're going to look at three things. Fabric itself, a basic overview. This is not a what is Fabric. But I've got to set the scene a little bit, because what Fabric is also affects how you approach it in terms of a proof of concept. I'll explain that at the time. We'll look at, well, what's a proof of concept? What are we looking to achieve in that proof of concept? And then we get into the meat of it, which is a set of resources provided by Microsoft. Now, they're not Fabric specific. I use these resources for Synapse Analytics, and now I find them incredibly useful for Fabric, until at such point there's going to be the same thing for Fabric, which I hope will be in the future. But it's to get your mind around what these processes are. So firstly, yes, what is Fabric? I think we're all legally obliged to have a slide about what is Fabric in any form of Fabric sessions. And really, the way that I'm explaining it is that it adds data warehousing, it adds data engineering, real-time streaming into the world of Power BI, where Fabric is really the kind of superset over Power BI. When Microsoft released a product called Synapse Analytics, it was almost like the other way around. They created this product that had data warehousing and data engineering, and they added in a bit of Power BI. The Power BI integration didn't really work, so what Microsoft have done is flipped it round and pushed these services into a software as a service solution. Hugely reduce the complexity in terms of what you're doing when you're provisioning compute, right? So we've got this concept of a Fabric capacity. That's what runs warehousing, lakes, Spark pools, pipelines, machine learning, real-time analytics. So you don't have to worry about understanding each and every different compute across a service, but of course, you need to understand how each of those services is using that shared compute. Now, it being a SaaS, software as a service, a lot of the control is abstracted away. With Spark, you get a lot of control, right? So if you're into your Python, your PySpark, Scala, then you're going to be able to run those workloads. You're going to be able to bring your favorite libraries, and it's all going to run. But a service like the warehouse, if you like configuring and you like to tinker and get in there, the warehouse service, all of that is abstracted away from you, and you've got very little control over what you can do there. And the biggest change is the fact that, well, the storage is underpinned by Parquet, a compressed column store file format, with Delta Lake, which is a service that allows transactional consistency between a compute engine and the Parquet files, something that was lacking in data lakes in years gone by. But of course, Delta Lake offers a whole suite of other features as well: time travel, rollbacks. Not going to go into that here. It's quite a big shift for Microsoft. Now, how does that actually relate? So we've got a nice Microsoft graphic, but really, why would you want to use Fabric? Well, it has the ability to deliver an end-to-end data platform solution. So we've got our source data. It could be on-premises file shares, servers, SQL databases. It could be cloud-based services, third parties, so on and so forth. And within the Fabric ecosystem, we can ingest that data, whether it's batch, whether it's real time. We've got options to process that data as well and store. Ultimately, we can deliver it. We can build models to reports. We've got machine learning. So it really is truly an end-to-end data platform solution. There's a lot going on. So when we look at scope of a POC, this is going to become quite important. Now, one of the quotes that I always like to think about whenever I approach any project is from one of the owners of a consultancy called Engine, Matthew Adams, where a POC is not a quick hack. If you want to do a hack, fine, do that before a POC. See if things are worth doing before you actually engage in a POC. The reason this is important is that when you're conducting a proof of concept, a POC, I believe it's important to represent the software that you're proof of concepting, or whatever you're proof of concepting, in the best way possible. If you hack something together, it might not actually work as it should because you've just hacked it together. So approach the POC with basically the respect that it deserves. Because ultimately, it's an experiment. You're trying to demonstrate a thing. Does the thing that I'm demonstrating come to a conclusion that I'm happy with? That's really a proof of concept. Is proof of concept could be anything. It could be going and trying a new car, or it could be finding a new route that you walk to work. I'm going to conduct an experiment and I'm going to see whether it succeeds or fails. Now, the success or failing was something I wanted to go out and ask people about and say, well, what's the definition of success in a proof of concept? Because we're setting up a proof of concept. We want to create a set of goals and some tests and actually see whether we get an outcome. And I went out on social media and I asked, well, how do we define success in a proof of concept? And overwhelmingly, people said, well, it has to prove that it works or doesn't work, i.e., the experiment has to be a success. You have to be able to finish the experiment and then analyze the results. So, for example, if the POC breaks halfway through, you haven't really got a true representation of that result. I mean, yes, if it breaks halfway through and it's unrecoverable, and that's just part of that particular software platform's issues, then yes, the proof of concept is going to end early and it's going to be a failure. However, if we can get to the end of that proof of concept, we can prove if something works or doesn't work to the criteria that we've set and that we want to assess. So some people might be a little bit worried about doing a proof of concept in that, well, how much time do we need to take doing this proof of concept? What happens to this proof of concept after it's finished? Is it time well spent? Well, what we can do is we can actually integrate the proof of concept into the product lifecycle. So, for example, our proof of concept is a working version. It could be an extremely basic working version, but it's a working version. Now, if that proof of concept ends up succeeding, then perhaps that goes on to be an MVP, a minimum viable product that we can build on. So it's not something that you can look at as always being scrapped when it's completed. It could be something that you can move on with. So all of that hard work, let's say to set up Fabric, to set up workspaces, lake houses, notebooks, isn't going to be in vain. I'm just going to check to make sure that everyone can still hear and see me okay. And if there's any questions in the chat. Okay, I would, if possible, drop questions in the chat if that's all right. But if everyone's okay, I'll carry on. So when we're running this POC, one of the factors is that, well, Fabric is a big product. There's lots of things in there. So when we talk about a Fabric POC, well, that can cover all sorts of things, right? So we've got, well, the concept of these lake houses. I'll come back to that question in a little while. We've got administration. There's user permissions. There's the warehouse service, Spark pools, data loading, so on and so forth. There's a lot here. One of Fabric's benefits is there's a lot here, but of course, the drawback is you're going to need to very, very clearly define what you want to proof of concept. All of this can get quite overwhelming. I go back to what I said before about the overall platform. It does a lot of things, and there are a lot of services to do those things. Perhaps if you want to conduct a proof of concept, it might be better just to concentrate on a part of the process. Yes, you're going to see loads of posts out there on social media, on LinkedIn, end to end. Here's some raw data, and we're going to build you a report. Great, brilliant. It does that. But to prove out certain aspects of the platform, that might not actually be the best way of going about it. So what I will touch on is the question of, is Fabric production ready? So certain services within Fabric are generally available and certain services are not. Certain features within those production ready, those generally available services, are still in public preview. So anything production wise has to be generally available. So I'm talking any of those services that are generally available, any of those features that are generally available. That's what you do in production. Now, does that mean that your proof of concept doesn't include preview features? No. you can include those preview features or preview services, but you have to bear in mind that you are not supported unless it's generally available. So that question, is Fabric production ready, comes with a lot of caveats, right? Overall, yes, I believe it is, but with caveats across these services and these features. So I'm going to take an example of the choices that you have in that, well, we've got these houses. So really, which do we want to use? We need to kind of define that before we can run our POC. And that's going to depend on what our POC actually is. So, well, we've got a warehouse, right? So the warehouse is really for your structured data warehousing models. So whatever your data warehousing methodology, whether it's a Kimball's dimensional modeling, so on and so forth, this is where it's going to sit in that service. It's structured data, right? It's not unstructured. It's not files. It's not images. It's tabular based data using very, very much T-SQL. And we're working within the familiar constructs of, well, a warehouse is in effect a database. So, for example, a workspace within Fabric or Power BI is like a server. So if you were to create 3 warehouses within your workspace, you are in effect creating 3 databases within a server. That's how it's going to be. That's how it's going to be shown in something like Management Studio. When we look at lake houses, well, lake houses are where we can store anything, unstructured data, files. We've got semi-structured, and of course, we've got structured data as well. And what we can bring is, yeah, obviously we can use Spark SQL, but this is now, we're in the world of data engineering. We're in the world of Python, PySpark, and Scala. And the way that data is organized is, well, there's files. So we have to bring our understanding of how data lakes are organized into the file system of a lakehouse. But of course, we can create tables. And again, if we create a lakehouse in a Fabric workspace, we will see that lakehouse as a database in a SQL client tool, let's say SQL Server Management Studio. And the last thing, Event House. So this is your real-time streaming. So this is the Custo query language, your KQL. So of course, if your proof of concept is about ingesting operational data from a source that is outputting streaming data, perhaps the Event House is where you're going to conduct your proof of concept, or that's going to be the storage that's going to underpin how your proof of concept is done. And of course, Microsoft had a decision guide. Now, I've got all the links to all of these in the presentation, so I can share those. When we're looking at architectures and deployments within Fabric, now we get into the workspaces issue of how are we going to lay out our workspaces. Now, I've dropped this in from the Microsoft documentation because that's what you'll find when you browse the Microsoft documentation. You'll see things like bronze, silver, gold with One Lake logos on there. But ultimately, well, where do these resources sit? Where am I putting this bronze lakehouse or this silver lakehouse or this gold lakehouse warehouse? How do I know how to set these things up? I don't really want to have to run my POC, and this is the thing that I've got to struggle with at the beginning. So Microsoft have put together, well, multiple scenarios for containing items, and this is a starting point for people to help them understand how they might want to set up their workspaces. So we'll start from a very, very simple, what they call monolithic. Now, to be honest with you, I don't really like the word monolithic, but that's what Microsoft have in their documentation. And this is where you have all of your items You've got your lake houses, your warehouses, your data loading pipelines, your notebooks, and your semantic models in a single workspace. Now, I'm not going to talk about different environments in this session, development, UAT, production, but suffice to say that this is the simplest method in terms of housing your items in a workspace. But there are some security aspects to that that may not fit with your particular scenario. So we move into a second scenario, which is now we're splitting out into multiple workspaces. We're still sharing the same fabric capacity, the same compute, but now we can separate our workspaces. Common for one of the big emerging patterns, the data mesh, in which perhaps workspace A is a particular business area in an organization, and workspace B is a different area of that organization. It could be finance or sales or marketing. But we're still using the same fabric capacity. And then the third is, well, what about if we don't want any noisy neighbors? What if we actually really need to separate our workloads within Fabric so that one set of workloads does not in any way impact another set of workloads? So we can then add in the fact that we can add multiple Fabric capacities and run those in a tenant and then assign workspaces to them. So maybe workspace C is an extremely critical, it could be finance, for example. Let's say it's finance that absolutely positively must not have any noisy neighbors from any workloads in workspace A and workspace B. So that can be a consideration. For a proof of concept, obviously monolithic is going to be one of the easiest things for you to look at. So I just want to touch on Fomi's comment here. So evaluating the success of a proof of concept, the mini project, important to note that the results may not accurately reflect real world outcomes as the volume of data plays a crucial role in determining success. Yes, excellent. We've got a point on that to discuss. Because it's no good using a gig of data if ultimately your production system is going to have 10 terabytes of data. Yeah, you know, it's going to work on a gig of data, but then what happens when you scale it up? Great point. Now, this complexity of all of the different items within Fabric and all of the things that you may want to do within an architecture, it might be an idea to just chain several POCs together. I've done this in the past. Literally, the last slide in this session is about timelines. But I'll touch on that now, is that really for a proof of concept, if we can choose the shortest timeline as possible, the better the chances of that proof of concept succeeding. If your proof of concept all of a sudden is spanning months or even several weeks, might be a case to break it down into smaller POCs. So what I mean by that is, well, perhaps your first POC is all about the raw lakehouse. Forget about the end-to-end. You want to prove out that you can get to your source systems securely. You can load your data in and you can surface it within a raw lakehouse. That could be your first POC. Gated into another POC in which, well, now we've succeeded in our first POC, we can move on. And now this is about the warehouse service and about modeling, let's say, a star schema, facts and dimensions, and delivering a semantic model. And then another proof of concept could be how you're locking down your Fabric environment, what permissions you're putting on your items that support your organization's requirements. Now, of course, that doesn't mean that network security and user permissions POC can't come before you touching anything to do with lake houses and warehouses. In fact, that might be the one that you do first. What if Fabric cannot meet your security requirements? So we'll touch on one of the questions here. So is the data mesh like a data mart in traditional warehouse? Well, so basically, data mesh is just a way of subdividing your data estate into business areas. Those business areas essentially are decoupled from a central bottlenecked, let's say, a central data team or a central IT team, in which each of those business areas involved in a data mesh are responsible for their own data loading, data cleansing, and surfacing of data. However, there is a top-down policy approach to make sure that data can be exchanged between those two services, between business areas. A little bit too much to go into, but that kind of multiple workspace is how you would set up data mesh within Fabric. And Fabric very much supports Kimball warehousing. In fact, if you browse the Fabric warehouse documentation, you will see front and center a menu item on the left that talks about the best way of building your warehouse, and they have dimensional modeling within there. They talk about different types of dimensions and different types of facts. So they've actually gone into detail about the different types of dimensions and facts that are available. So yes, Kimball is front and center there. Now, back in the Synapse days, I found a set of resources incredibly useful, which is, and that QR code will take you to the page. We'll have a look at it in a bit. Yes, it's about Synapse, but I find a lot of common ground with Fabric. Now, essentially, this was put together by the CSE team at Microsoft, the customer success engineering, about their experiences when implementing Synapse Analytics across organizations, what they learned when they went into clients, how was the best way to approach it? And they learned this over time. And it's split into two parts. So they've got playbooks. Dependent on the services that you're provisioning, look through one of these playbooks and align what you're doing with one of these playbooks. And they've got another part, which is the implementation success by design, which is how to monitor what you're doing to make sure you've got the best chance of success. And I found these resources very useful to be able to break down what I wanted to test and how I wanted to test that. So just very quickly. In the Synapse documentation, we've got this guidance and we've got this Azure Synapse Success by Design. Basically, you can search for it on Google, Synapse Success by Design, in which we've got a series of playbooks, and then we've got this methodology to make sure that you're implementing it in the right way. Won't look at those, but look, we've got data warehousing with dedicated SQL pools. We've got data lake exploration with serverless, big data analytics with Data Explorer, so your real-time streaming, and your Apache Spark. So they will go into a set of steps. Oops, excuse me. Go at the top. Okay. Now, obviously, there's far too much detail in here for me to put into a PowerPoint presentation because it's a little too much. I've pulled out the bits that I find very useful. But of course, if we're looking at Spark pools, it's telling us about Apache Spark, compute and storage. All these things are relevant when we're looking at Fabric Spark pools. There's goals, there's examples of what you're doing with your POC. Extremely useful. I found it extremely useful. Just going to go back to the PowerPoint. So when I've conducted these, what I've looked at is the playbooks available, right? So we've got dedicated SQL, serverless, Spark, and Data Explorer. And really, I'm not going to compare dedicated SQL pools with the Fabric Warehouse service. I am going to look at it from a process perspective. I want to warehouse data in dedicated SQL, and I want to warehouse data in Fabric. I'm not going to look at the technology, I'm just going to look at the process. Now, just as an example, I'm going to pick Lakehouse loading. Now, there is no concept of a playbook that tells you about Lakehouse loading, but I want to load data in and I want to query that data. Sounds simple. But when I'm preparing for my POC, well, the first thing that I really need to do is sponsors. So who's sponsoring me? Could be head of data, could be the CIO, it could be the CTO, CFO. There needs to be people that are aware that you are running this proof of concept, because you're probably going to need budget for this and time and resources. It'd be really good if someone was able to champion this to the business. Is there anything that might prevent you from even starting to look at a Fabric POC? What's your security posture within your organization? Are URLs locked down? What do you need? Anything that's going to stop you actually being to access and carry out the proof of concept, you need to list down. And this is political blockers as well. These are things that can taint a proof of concept. So get those identified as soon as possible. Use cases. Basically, why would you even want to conduct a Fabric proof of concept? Don't do it for the sake of doing it. Maybe investigate, sure. There has to be a reason that you're doing this. Now, some of the criticism in the past of Azure services is that you're having to glue together lots of different services, lots of different ways those services connect to each other and permissions, and some services support some things and other services don't. Maybe that's your pain point. Maybe you want a service where all of this is a lot simpler. But you need that why. Why are you doing any of this? Now, the architecture is going to be based on your provisioning of your workspaces, how you're going to put these things together within Fabric. Are you going to go with a single workspace? Are you going to go with multiple workspaces? Do your semantic models sit in a different workspace? You're going to have to sit down and design your Fabric infrastructure as simple as possible. We don't want to over egg the pudding here. What you don't want to do is go into your proof of concept and then have to decide, oh, where are we going to put everything? You have to basically learn up front what is and isn't supported if you put single or multiple workspaces. Now, that point about the volume of data, yes. So we're going to identify the data sets. So if it's within a particular area of the business, perhaps we can identify some data that we can use in our proof of concept. Maybe there isn't the volume of data there, but we still need to prove out that this particular data set, with all its idiosyncrasies and complexities, because we know what business data is like, can we implement that within our proof of concept? Scale and size, that might come with you having to synthesize volumes of data. Plenty of ways to do that within SQL and Spark to over exaggerate a data set so you can prove out the technical aspects of how these systems scale. Now, are we migrating from an existing system? Do we have an on-premises SQL server? Everyone's got excited and they want to move to Fabric. Well, how are we going to migrate? We've got data loading processes. We've got to get the data into a location that we can access it. Security. How do we basically migrate from a current system to a new system if that's what we're doing? If it's greenfield, perhaps you don't need those migration considerations. As a point on that, Microsoft have valiantly attempted to provide migration tools, haven't really worked out in terms of the data side of things. I think there was a project called Synapse Lighthouse. It didn't really work, to be quite honest with you. Set your goals and your success. What are you measuring? How will you decide whether something that you've done is considered a success? One of your goals might be, well, this particular piece of data, we have to be able to run a query on it that returns within 30 seconds or 10 seconds or 5 seconds. That's going to be a goal. That's going to be your success criteria. Testing. So how are you going to test? Have you got a series of, let's say, Python scripts or a series of SQL scripts in which you need to validate results and then note down those results? Timelines. As I said before, look, we're not looking at spending weeks and weeks and months on a proof of concept, because all that's going to happen is it's just going to drift. The longer you take on this proof of concept, the more chances are that it's going to fail. And the more chances are that things creep in. Oh, we might be able to try this and add this in there. And, oh, the proof of concept is only really valid if this thing is included. Well, let's make sure that's included in from the start and we don't have any kind of creep involved. Who's going to do it? Now, all of these things here, identify sponsors and test plans and timelines and blockers, they're all things that you can do in parallel, really. Maybe the most important thing for you at the time is identifying the team, i.e., who's going to be the one that goes out to the business and speaks to the sponsors, who's the person that's going to do the high-level architecture, so on and so forth. If it's just you, it's going to be just you. Now, in terms of what we're doing to put the POC into practice, we've got to set things up. Now, setting things up, I don't believe should be part of the proof of concept process, because that's going to take time from what you're actually trying to prove in your proof of concept. So when I talk about setup, I'm talking about the fact is, do you have access to a Fabric tenancy? On day one of your proof of concept, it's no good if people turn around and say, well, how do we access it? Do we have a capacity? Do we have some workspaces set up? Right? You're going to have to look at setting those things up beforehand. Load your data. Doesn't matter whether you're using a lake house, a warehouse, but lake house here, or an event house in terms of real time, right? You're going to want to implement your data loading patterns. Could be PySpark in notebooks, it could be SQL, it could be KQL, right? We're loading our data. Now, in terms of running multiple workloads against each other, yes, that's worth doing. You're running SQL queries, for example, or Python. Look at your concurrency, okay? Because one of your tests and one of your goals might be that, well, actually, several people need to access this at the same time. Okay, make sure that you're going to do your sequential query tests in there. Or sorry, your sequential query tests in terms of one query after another, your concurrent query tests in terms of multiple queries running at the same time. And again, this could be across any of those services. Now, with mixed workload tests, this is going to be important in something, let's say, the warehouse. We're loading data, but also we want to query data at the same time. Now, one of the benefits of using, let's say, the warehouse in Fabric is that it has optimistic concurrency. It has and uses snapshot isolation, which is, essentially a feature of Delta Lake. We can load data and modify data at the same time we're reading data. And Fabric also has a compute boundary in terms of operations. So what Microsoft do is they actually separate ETL operations from querying operations. But do your testing, load your data, query it at the same time. Do you get the results that you want based on your goals? And optimize the data. Yes. So in terms of a lake house, perhaps you've got to go back and partition. Perhaps you've over partitioned and it's affecting the performance of the SQL, the lake house SQL endpoints, or it's affecting reading and writing because you've over partitioned or under partitioned. Go back and look at optimizing your data. It could be data types. And then the value added tests. So, for example, accessing the Fabric UI. How do people run workloads? Can they connect with client tools? So it's these other things that surround the core processes that you're doing. Excuse me. So in terms of creating the resources, right, again, one of the benefits of Fabric is that we can just jump in. We can open the GUI and we can just start creating objects. Click, 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 create a warehouse, create a lake house, create a pipeline. Brilliant. Really good. However, in practice, it might be very useful to create a repeatable process in terms of deploying these resources. So at the moment, infrastructure as code processes like Terraform are lacking. They are coming. So I think there's on the Fabric roadmap. So if you just type in Microsoft Fabric roadmap, it breaks down what's coming in terms of one lake, warehouse, lake house. Excellent. Part of that is the infrastructure as a code is coming in the form of Terraform. So at the moment, how do we build repeatable patterns in order to create these resources? Well, we do have the Fabric REST API to do that for us. So for example, I can issue a command to that REST API and I can say, in this workspace, I've replaced the long GUID with just a placeholder GUID text there. And I'd like to create a lake house called POC Raw Lake House with a description in this specific workspace. So instead of me having to go into the GUI and say next, click, next, lake house, give it a name, I can just build this into a repeatable process. And the same with the warehouse, right? I can create these items using the REST API. It's possibly worth doing if you're going to do several proof of concepts. What I've done in my own tenant is I've actually created a workspace with several default items, a lake house, a warehouse, a pipeline, a notebook, and I've connected that workspace into source control, into a DevOps. Actually, I've started to use GitHub a lot more. And when I've wanted to just get a workspace up and running with a few of these items, I've just either cloned the repo or I've just taken a branch. There's a couple of other ways of doing it, but the REST API is also a very, very good process to get up and running with, because you can do a whole bunch of stuff with just a bit of code rather than the GUI. So just stop for a question. So would you suggest beginning with the Fabric SKUs from F2 and scaling up as necessary during the POC? The trial Fabric is F64 and everything's functioning well with most of the workloads. Yes, this is incredibly important. Now, by all means, start with an F2, but one of the questions that I see quite a lot on forums is, I'm running an F2 and things are just failing and I can't get these notebooks to run and these pipelines to run. F2s are incredibly small capacities. So if I were to liken it to cores, for example, in the warehouse, for every one CU, you're allowed 0.5 vcores. So really, in an F2, we've got access to one vcore in total. So if we were testing our warehouse processes, we've got to bear in mind we've got one vcore. Now we can burst So it's gonna, the workloads can burst beyond that capacity, and we've got a scale. We've got a guardrail in terms of how much it's gonna burst beyond. 16 times the capacity units, and so on and so forth. And you'll see that in the capacity metrics app when you're doing your workloads. Is my F2 really, really struggling? The other thing is, it depends are there features within specific Fabric SKUs that you need to be in your proof of concepts? Copilot, for example, if you're doing a proof of concept on Copilot, you're not going to be able to do it on anything other than an F64. But yes, it's, the reason that Microsoft have got these different SKU sizes is that, well, you can adjust the SKU size based on your workloads. Not everyone needs an F64. I'm probably going to say that most people are going to need more than an F2, but by all means, test it, right? It's going to work or it's not going to work. You're going to be either massively throttled, and you'll see in your capacity metrics app that you've bursted beyond your capacity far more than you should do. Therefore, you're probably going to have to bump your capacity up a little bit, or modify what you've got in your data loading. So timeline. So this is basically the last thing we'll talk about. It could have been the first thing, but like I've said, when we're running our proof of concepts, we really, really, really don't want to be running these proof of concepts for too long. Things drift. The likelihood is it's going to fail. Things change. Now, a 2-week timeline for a POC sounds quite aggressive. What that does mean is that you're setting up your environment beforehand, so that on day one, you're not setting up workspaces or capacities. So perhaps your very first proof of concept is setting up the environment. Can we get our environment set up how we want? Maybe you spend 3 days on data loading, writing the code required to load data into a lakehouse. Perhaps you're going to then spend 5 days doing all sorts of workload queries on that data to make sure that, well, number one, your capacity isn't struggling, that you've got it on, for example, that everything is it's meeting your SLAs and your objectives in terms of how long those queries are running for, and the concurrency of those queries, and documentation and validation. Yeah. First, the last thing you want to do is, well, as you're going along, you should be documenting how long things are taking to load your data, and how long things are taking to query your data. You document that, validate, and ultimately, at the end of this timeline, hopefully your proof of concept has succeeded and it has met your objectives, and you can maybe move on. Maybe that's going into a minimum viable product. Maybe that's a gated process for a next POC. That's up to you. But I think that's about time. So thank you. Thank you for your time. I hope that's been useful. These are resources that I've used in the past that I'm now transitioning into using in Fabric. I'm probably going to blog about this in the next sort of few weeks, because I want to define a checklist that I'm working to within Fabric. But again, any questions, reach out to me on LinkedIn. I'm on Blue Sky, so you can probably find me on Blue Sky. But again, thanks everyone for watching.